Okay, students, good morning to all. Now, today I'm going to continue the gravitation chapter. We know that previously we discussed about a few topics, right? And I'm going to continue the topic, my voice, and the board. Is it clear, students? Now, you listen very carefully. If you have any doubt, you write in the chat box. Okay, right. I'm going to start the gravitational potential energy. Actually, already gravitational potential energy we discussed. Okay, and once again I will revise. Potential energy means energy possessed by a body by virtue of its position or state. Due to position or due to the state, if any body has, that energy is said to be potential energy. We derived the formula for the potential energy, right? Potential energy formula we derived. The potential energy is the negative, right? Potential energy of body, potential energy of a body, okay, which is at a distance smaller from the center of center of earth. This object potential energy I want to know the potential energy of this object. There is a direct derivation will be there. Potential energy is the product of force and distance between the two objects. Okay, that is F into R we can write. But the F is the gravitational force between these two objects. What is the gravitational force between these two objects? G M1 M2 by R square. M1 is capital M, M2 is small m by R square into V write is smaller. The potential energy formula is very simple. That is potential energy formula is minus GMM by R. This is the formula for the potential energy. It was very simple, right? Have you understood? Is it clear, students? Voice and picture? Write in the chat box. Now I was able to see the chat box also. In the different method we derived in the last class. Now it is the shortcut method to derive the gravitational potential energy. We derived the gravitational potential energy, right? And you are going to note some points in the note. Okay, note the some points in the note, right? And that is gravitational potential energy formula we got is minus G capital M small m by capital small r. Okay, this is the gravitational potential energy of a body which is at h height, which is at smaller distance. 1 minute actually the board is window is closed. Again it is opening. Okay, within 1 minute it will be set. Right, it is opened. Now previously just now what we discussed that I will open. Right, the gravitational potential energy we are discussing. This is the formula for the gravitational potential energy. In the note you noted some point that is, what is the formula for the gravitational potential energy on the surface of earth? What is the formula for the gravitational potential energy on surface of earth? Gravitational potential energy, gravitational potential energy on surface of earth. Okay, right, for example this is a earth. its mass is capital M. Okay, this is the Earth. On the Earth, one object is there. This object mass is small m. Then the distance between these two is capital R. The gravitational potential energy formula we derived previously. We have to take the distance between these two. That is the gravitational potential energy is equal. It may be denoted with U. Okay, that is minus G capital M into small m. It is the mass of the Earth, mass of the object by distance between these two we have to take from the distance from the center of Earth to center of object. That is the capital R. Right. This is the formula for the potential energy of object on the surface of Earth. Okay. M is what here? Mass of object. M is the mass of object. What is capital M? Mass of Earth. Capital M is the mass of Earth. What is capital R? Radius of Earth. Capital R is the radius of Earth. This is the first important point in the gravitational potential energy. One more point I am going to give, that is, for example, you are lifting work done to move an object from R1 to R2 distance, from I want to move an object from R1 to R2 distance from the center of Earth. Our distance is measured from center of Earth. You see here, this is Earth, this is Earth. Okay, initially, for example, the object is at M1, M height, R1 distance from the center of Earth, and then finally I want to move the object from A to some B. Okay, the B point is at R2 distance. I want to move up to here, A to B. I want to move the object from A to B. That the B distance is R2 from the center of Earth. This is Earth. I want to move the object from R1 to R2. For that, how much work we have to do? That work is equal to change in potential energy. That is the final potential energy minus initial potential energy. You remember it. That work, change in potential energy formula is what? Initial potential energy, final potential energy is what? That we write is minus GMM by potential energy formula R we have to take. This is the final point. Okay, work done to move from A to B. A is initial, B is final. Students, are you getting the clarity? Write in the chat box. Is it clear, students? If are you getting any doubts? Minus GMM by R2, final potential energy, minus initial potential energy is minus GMM by R1. Right? This is the formula to find out the work done. Okay. If you have any query, right, if you have any doubt, don't hesitate to ask. You must ask me and get the clarification from me. Okay, today's topic is the most important. Surely it will come in the exam, final exam. Okay, if you simplify this, what you will get? For example, if you want to work done it here, if you not understood any step, you ask me. Okay, G capital M into small m. We can common the G capital M into small m it here. Here we will get minus 1 by R2 plus this minus minus plus it you will get 1 by R1 you will get. Then work done formula you will get is G capital M small m into 1 by R1 minus 1 by R2. Here which is greater? R2 is greater than R1 na? R2 is greater than R1 in this. Yes, work you will get is positive. Work is positive because R2 is greater than R1. Is it clear, students? Is there any doubt for you? R2 greater than R1. If any step, whatever it may be the step, This step is doubt, sir. You can ask. Don't hesitate. Right? And now this is the second point in the note. Third point I am going to give. What this negative shows? Negative potential energy indicates that negative potential energy indicates that object bind to the earth with some energy, that is called as the potential energy, right? Okay. And now fourth point is that we derived the change in potential energy. For example, in the previous case also we derived the change in potential energy. What you derived the change in potential energy? For example, you are taking the object from, this is the earth. Initially the object is on the ground, its height is h, and finally we are taking to h height. Okay, in this moment the change in potential energy is equal to be derived at here, that we got is mgh by 1 plus h by r. In the last class we derived, right? If this change in potential energy equal to mgh, when it will be, if h less than r, this can be h by r is less than 1, then we will get if h less than r, then we take change in potential energy as mgh. Okay, this is about the potential energy. Okay, and one more important point in the note I will tell. Okay, good. Alok, Jaya, Divya, Rohan, right? And now next one is the potential energy of system I want to tell. I am going to give some more points. There is a one note I will give, and later important topic I am going to start. That is the important point. One more thing is that, for example, there are three particles. Okay, three particles of masses, three particles of masses m1 comma m2 and m3 are at the vertices of triangle. Then find potential energy of system. Find potential energy of system which has three particles. You see here they gave the one diagram it here. This is a triangle. It has m1 particle at one vertex, m2 at other vertex, m3 at other vertex, and these have the sides r1, r2, r3 like this. Okay. Then potential energy of system is what? Between these two particles is potential energy is there. That, and between these two particles potential energy is there. Between these two particles potential energy is there. How many combinations will occur? That many potential energies will be there. That's why we write as u1 plus u2 plus u3 we write. U1 is considered the potential energy between M1 and M2 minus G M1 M2 by R1. Next, minus between these two we can take U2 M2 M3 by R2 minus G, between these two also potential energy is there, M1 M3 by R. This is the formula for the potential energy now, right? Is there any doubt, students? Is it clear? This is the potential energy for the two particles. We derived the potential energy for two particles. For these two particles, minus gm1 m2 by r1. For these two, minus gm2 m3 by r2. For these two, minus gm1 m3 by r3. This is the formula for the potential energy. Can you find the potential energy of four particle system? For example, this has m1 and m2 and m3. Okay, and m4. For example, all the particles are at the having the same mass, and they are kept at the sides of some square, let us consider. Then what is the potential energy of system? potential energy of system I want to find out. How many types potential energies will be there? For example, I am taking if m1 is equal to m2 is equal to m3 is equal to m4 is equal to m. Let us consider in the question they give. Can you find the potential energy of the system? How many combinations you will get? Write in the chat box, students. How many combinations you will get? How many combinations you will get at here? And just you write the combinations. Alok, tell me the answer. How many combinations you will get? Today's topic is very important, and it is going to start. It is a square. Okay, in the diagram they gave us a square. Okay, I think little bit it is not appearing na because of my photo. Right, students. Oh, this is the side. Okay, it is a square. All the particles have the masses same. How many combinations will be there? Combinations I want. Four combinations, right? Okay, Alok give the four combinations. देखिए M1 M2 one combination, M2 M3 one combination, M3 M4 one combination, M4 M1 one combination, and diagonally also we will get the two combinations which are distinguished combinations. M1 M3 combination not came, M2 M4 combination not came. That means there are totally we will get the six combinations. We write here like this: u1 plus u2 plus u3 plus u4 plus u5 plus u6. Can you find it? Okay, I am leaving the for you to find the potential energy. Will you find it? Will you find the potential energy of that system? Will you find, students? No. Yes, I am seeing you wrote four chart. Alok, I am looking. It is appearing. Okay. Uh, Actually, four, it is not four combinations, Alok, because diagonally we will get along the four sides we will get the four combinations, and diagonally we will get the two combinations. Total six combinations we will get, Alok. Are you understand, Alok? Okay. Now next topic I am going to start. This you can continue. This continuation you can follow. And now I am going to explain the next topic, and that is very very important in this chapter. Right? In this chapter, the most important topic now I am going to start. You listen very very carefully. Okay? Right. What is that important topic? Escape velocity formula and orbital velocity formula I am going to derive. Okay, you listen very carefully. Right? What is escape velocity and what is orbital velocity? Okay, for example, uh, okay, the topic is what? Escape velocity. Very very important. 100% either escape velocity or orbital velocity. In these two, any one question will come for the 3 marks. Okay, that's why you listen very carefully and you try to learn and everything, and if you have any doubt, any query, right, you can write in the chat box. This is our topic. Our topic is escape velocity. What is escape velocity? Escape mean the name only it is there. Escape means for the escape without coming back. If you want to escape, right, with how much speed you have to go, right? Let us see here. This is the what is the definition for the escape velocity? Who is escaping from where? Escaping, right? Escape velocity means the minimum velocity. Its definition is the minimum velocity. Escape velocity means the minimum velocity required to escape from the Earth gravitational field. The minimum velocity required for a body to escape from Earth gravitational field. Okay. The minimum velocity. The minimum velocity required for a body to escape from to escape from Earth gravitational field. In order to escape an object from Earth gravitational field, how much velocity you have to give? That velocity is called as escape velocity. That means if you will throw any object with that velocity, it cannot return back to the gravitation earth field, and it will not fall on the earth field. It will escape. It is denoted with V suffix E. It is denoted by V suffix E. Okay. This is the escape velocity. The minimum velocity required for a body to escape from Earth gravitational field is called as the escape velocity, right? And now I am going to derive the formula for the escape velocity expression. On what factors the escape velocity depends. Okay. Now you see here, this is the Earth. This is the Earth, and the Earth has the radius capital R. Earth has the radius capital R. I want to throw one object whose mass is small m, okay, with certain velocity v. Then in order to, for example, if you throw, generally you know that if you throw with certain velocity, okay, for example, I am throwing from the Earth surface, I am throwing an object. For example, with little speed, if you will throw, then it will go up to here and then it will return back. If you will increase the speed some more height, it will go and return back. If you will increase the speed some more height, it will go and it will return back. Then like this, for certain speed, what happens? The object will be escape from the Earth gravitational field. Okay, it will enter into the space, right? Then with how much velocity you have to throw an object in order to escape from the Earth gravitational field. Okay, in the Earth gravitational field, if it is there, for example, this is the Earth gravitational field exists up to a particular region. If object goes up to here, then it will come back. Up to here, it will come back. Up to here, it will come back. But if object escape from the Earth gravitational field, up to here, this is the limit of the gravitational field. Now the object never return back to the Earth. Never return back to Earth. This is the gravitational field. Means in this region gravitational force of earth exists. If any object escape from that field, then that object will not return back to the surface of earth. That means in order to escape from the earth surface, with what velocity you have to throw, then the minimum velocity required to escape from the earth gravitational field is called as escape velocity. I am going to derive the expression for the escape velocity, and then I am also going to tell with how much velocity you have to throw an object in order to escape from the earth gravitational field. With what velocity you have to throw. Is it clear definition, students? You should respond. You should respond. Kashmir Shoi, present sir. You should respond. If you respond in the class, if you write something in the chat box, then the class will be active. Right. And listen it here. I am going to derive the expression it here. Expression means formula I am going to derive. Okay. And now consider, actually, in order to escape from Earth gravitational field, we should give the kinetic energy. Okay, that kinetic energy, how much it is minimum equal to the potential energy. Actually, potential energy is the negative. With that much energy, potential energy is the negative. With that much energy, this object is bind and it is pulled towards the center of Earth. Object is pulled towards center of Earth with some energy. That is the potential energy. The potential energy is not allows the object to escape. पोटेंशियल एनर्जी, एक्चुअली पोटेंशियल एनर्जी क्या करता है, उसको अर्थ सरफेस से दूर जाना नहीं देता है. हम लोग काइनेटिक एनर्जी देते तो क्या करता है, ये एनर्जी ऑब्जेक्ट को दूर फेंकने के लिए ट्राई करता है. दैट मींस नाउ one energy, the potential energy not allow the object to escape from the earth, but if you supply the kinetic energy, then it will go. But if that kinetic energy, in order to escape from the earth gravitational field, in order to escape from the earth gravitational field, from earth gravitational field, what we have to do, we have to supply the kinetic energy, right? Then the minimum kinetic energy of body, kinetic energy of body must be equal to the potential energy, must be equal to potential energy or greater than also, no problem. If more than that you will give means it will go fast. The kinetic energy of body must be minimum, this one, minimum kinetic energy of body must be equal to its potential energy, right? And that means in order to escape, the condition is that the kinetic energy equal to potential energy. What is the formula for the kinetic energy? Of mv square. We are throwing an object m mass, right? That's well its kinetic energy of object, kinetic energy of body of mv square, but we are throwing with velocity ve. That's well of mv square is equal to minus potential energy formula. What we can write? What is the formula for the potential energy on the surface of earth? Right, minus g capital M small m by capital R. Is it correct? But already minus is there. Why already we wrote the minus? Because potential energy is the energy with which the earth binds the object. Then we have to provide the kinetic energy to the body to escape from the earth gravitational field. The supplied kinetic energy is against to the potential energy. That's why we have to write minus, of minus gmm by r we have to write. Okay, this is the formula for the potential energy. Previously we derived. Is it right? If you have any query, right, in any step, you must ask me, don't hesitate. Okay, right, minus minus plus, then you will get here g capital M by r. Then escape velocity formula we are getting as under root 2 under root gm, sorry, v square by left side 2 is also there na, 2 is also there. Then we take that v square formula we write, v square is equal to 2gm by r you will get, right? And now escape velocity is equal to, we will get as under root 2gm by r. On what factors the escape velocity depends, right? This is the expression for the escape velocity. Okay, and in this, what is escape velocity? Escape velocity of a object, escape velocity of object, okay, depends upon, tell me from that. Depends upon mass of planet, for that is a capital M. It may be, you may find the escape velocity from moon also, no need to take the earth, right? Any planet you can take. That means escape velocity of object depends upon the mass of the planet. And one more is what? Radius of the planet also. Is it right? Radius of planet also it will depends. Radius of planet is what? R. Is it right? That means different planets have the different mass and radius. Due to the on different planets escape velocity is different. For example, if you want to, till now any doubt, students? Good, 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 good. All the members are replying. Clear, clear, clear. Okay. Suraj, Suresh, Baby, Mato, Manoj, Suraj, Ashish. Okay, everybody clear. Okay, thank you to all. And if you have any doubt, you can ask me. And this is the escape velocity formula, right? We can find out on the earth surface how much energy we have to, how much velocity we have to give in order to escape from earth surface. For that, what we have to do it here, listen very carefully, right? What happened? Again, I closed this one. 1 minute, actually I closed the window by mistake. I am going to open it again. It is going to open only for 1 minute. You wait. Only 1 second. What we derived it here, we derived the formula for the escape velocity. and I want the acceleration due to gravity on the surface of Earth. What is the formula for the acceleration due to gravity on surface of Earth? Can you anyone write in the chat box? What is the formula for the acceleration due to gravity on surface of Earth? Small g is equal to capital G capital M by R square. You know this one? Na? Then according to that formula, if you change escape velocity formula in terms of acceleration due to gravity, then how it will be there, right? It is take. Can write in the chat box. Okay, escape velocity formula in terms of acceleration due to gravity. I want in terms of acceleration due to gravity. Can you tell escape velocity formula in terms of acceleration due to gravity? Right, the board is opened now. Okay, we will go for our topic. Okay, you see here where we are now. We derived the escape velocity formula, right? Okay, this is the formula for the escape velocity. Okay, right. Now escape velocity formula in terms of acceleration due to gravity I want to find out. But we know acceleration due to gravity formula. What is the acceleration due to gravity formula? Acceleration due to gravity formula on surface of Earth or any planet. Yes, due to gravity, small g is equal to we write as capital G capital M by R square. From that, if you write the capital G capital M, we will get as GR square. This is considered as the equation 1 and this is equation 2. You write it in place of GM GR square. Then escape velocity from equation 2 substituted in 1. Okay, equation 2 substituted in equation 1. If you substitute, then what you will get? Right? Can you tell escape velocity formula what you will get? If you substitute, then we will get as VE is equal to VE is equal to we will get as under root 2 into GM. This GM we write as GR square by R we will get. And finally we will get as V is equal to under root 2GR. This is the formula for the escape velocity in terms of acceleration due to gravity. Escape velocity formula in terms of acceleration due to gravity. And G is the acceleration due to gravity, R is the radius of Earth. I want the, for example, escape velocity on Earth if you want to find out. Escape velocity from equation 1 and 3. Okay, from equation 1 and 3, escape velocity is independent of mass of object which you are throwing, right? Escape velocity from equation 1 and equation 3, we have the two formulas for the escape velocity. Then from that we write as escape velocity is independent of mass of object. Is it right? Independent of mass of object that you are throwing. Is it correct? On small m it is not depending because small m is cancelling. Then and we can write in on Earth I want to find out the escape velocity value. On Earth G value you know is 9.8 meter per second square and R value you know is 6,400 kilometers. Kilometers convert into meters, 10 to the power of 3 meters. If you substitute these values in the equation 3, we will get as 2GR, G is 9.8, R is the 6,400 into 10 to the power of 3. If you simplify, we will get as 11.2 into 10 to the power of 3 meter per second we will get. Now this is nothing but 11.2 kilometer per second. If you throw any object with this much velocity on the earth, then it cannot return back and it will escape from the earth surface. This is the escape velocity. Okay, in order to escape from the earth surface, we have to throw an object with an velocity that is equal to the 11.2 kilometer per second. What about the escape velocity on the moon? For example, you are throwing an object on the moon, then what is the escape velocity? Right? I want. Then for that, let us see here. I want the escape velocity on the moon. Escape velocity on moon, how much it will be there? Escape velocity on moon. Okay, on moon, acceleration due to gravity on moon is okay. Acceleration due to gravity on Earth by 6. Okay, that means 9.8 by 6 meter per second square you will get. Then if you substitute the radius of the moon also, I think it will be less. Then if you find out the escape velocity on the moon, I think 2.3 kilometer per second you will get. Okay, right. And this is about escape velocity. Okay, and for example, some note I will give. You are throwing from the surface of Earth means this is the formula for the escape velocity. For example, in order to throw at certain height, in order to throw an object at from certain height, then what should be the escape velocity? In order to escape from Earth gravitational field, Earth gravitational field. Okay, from the surface of Earth to the Earth gravitational field, we know that. But I want to throw an object from certain height, right? This is the radius of Earth and this is h height. From here I want to escape an object. I want to throw. What is the formula to find out the escape velocity at h height? Escape velocity on surface of Earth we derived, but escape velocity at height h. What is the formula? At escape velocity at height h, very simple. Escape velocity at height means we derived previously on surface means surface distance we took, that is under root 2 gm by r, but here r plus h bus. On surface means under root 2 gm by r formula we derived, but at height h means we have to take at height h distance we have to take, that's all. Okay, in terms of g, if you want gm is equal to gr square, we write like this 2 gr square by r plus h, because we know g is equal to gm by r square, we know na, because we know that g is equal to gm by r square. From that gm formula we write as gr square. What is capital G? Universal gravitation constant. What is capital M? Mass of the earth. Have you understood till now? This is about escape velocity. That escape velocity formula derivation up to equation 3, it is very important. And the next topic is, for example, I am throwing some object with a velocity that is equal to 1 by n times of escape velocity. Then how much height it will go? Okay, that is the note point it is. Okay, I am going to give in note. Clear na students? Right. Now, uh, I'm going to give one point that if object is if a object is thrown with a velocity is equal to the is equal to the 1 by n times of 1 by n times of escape velocity from the surface of earth, from the surface of earth, then find the maximum height reached by it, maximum height reached by it, how much height it will reaches, maximum height reached by it. Okay, this is our question. And how to find this, how to solve this problem? Okay, very simple one, and you listen very carefully. This is the earth. Okay, this is the earth, and the earth radius is capital R. I want to throw one earth mass is capital M. This is the earth. From surface of earth I want to throw one object. This is an object whose mass is small m. What I want to do, I am throwing this object with certain velocity v, that is equal to 1 by n times of escape velocity. Okay, then solution for that, I am throwing an object with a velocity that is equal to 1 by n times of escape velocity by n. Then question is that how much height it will rises, because actually here I am taking that in the question they gave that n is greater than or equal to 1. Okay, then at that moment what happens, we are n equal to 1 means v equal to v v if v is equal to n is equal to 2 means v by 2, v is 11.2 by 2, you will get 5. With 5 kilometer per second we are throwing, then the object never escape from the earth gravitational field, it will return back to the ground. Then maximum height how much it will go, that is our question that we have to derive. Understood, right? Then for the purpose what we have to do it here, for example it goes to h height. Okay, it goes to h height, and h after going to h height its velocity become 0, because while going upward velocity decrease after going to some height its velocity become 0, right? Then we have to take this point as velocity 0 point, and then we know that according to law of conservation of energy, according to law of conservation of energy, what we know according to law of conservation of energy, the total energy is constant. Total energy is constant. Total energy constant means, what is the total energy on surface of earth? On surface of earth total energy we write as potential energy. We can take this point as a, this point as b. Okay, potential energy at a plus kinetic energy at b is equal to potential energy at, sorry, potential energy at a plus kinetic energy at a is equal to potential energy at b plus kinetic energy at b. Total energy is constant. Potential energy formula at a is what? That is minus g mm by r. It is a formula for the potential energy. Kinetic energy formula is what? Half mv square. We are throwing with velocity v. Okay, potential energy at b is what? At here, potential energy formula is minus gmm by r. R is the distance between the object and this earth. From center we have to measure. You remember in the gravitation every time we will measure from center of the planet. That's why the distance become r plus h now. This is r and this is h. Total distance at point B become r plus h. Potential energy formula we know minus gmm by r. R is the distance. On surface means surface distance we took r. H height means h height distance we have to take. H height distance from center is r plus h. Plus kinetic energy formula at point B the velocity becomes 0. That's why the kinetic energy become 0. Then we have to simplify some more at here, and we have to write here minus g capital M into small m by r into half m. Here we know that v is v by n. We are throwing with a velocity that is equal to 1 by n times of escape velocity. Then we write as v square by n square. V, because v is equal to v by n, na? That we substituted it here. Then minus gmm by r plus h we will get. Now we have to simplify it. We know v square formula that we can write here. What is the formula for the v square in terms of mass of planet and radius of planet? Okay, v square, this one we write as 1 by n square and 1 by n square. V square formula we write is, v formula is what? V formula is what? Under root 2 gm by r. V square formula is what? We will get as 2 gm by r. Is it okay? Minus gmm by r plus h. Now we have to simplify it. Okay, and for that what we have to do, anything common means we can do, and cancellation. Okay, then we have to see here g capital M small m. G capital M small m. These two bits cancel. G capital M small m. Everywhere G capital M small m is there. We can common and cancel. And then minus 1 by r will remains here. Here 1 by n square r you will get. 1 by r n square you will get. On the right side minus 1 by r plus h you will get. Now we have to simplify it and find the h value, height value, what height it will go, right? Then for that we can find out what we have to do. We have to simplify it. We can we can take the 1 by r plus h formula here. 1 by r plus h. Okay, then we will get is you can multiply with minus 1 by r minus 1 by r n square you will get. Now 1 by r plus h is equal to, we can common the 1 by r at here, and 1 minus 1 by n square you will get. Is it right? Now we have to simplify it. What height it will go? Now is it clear, students? Right, let us go for it. Then for that okay, Nandini. Right, next we have to simplify it. 1 by r plus h is equal to, we will get as 1 by r into, we will write n square minus 1 by n square we write, and we have to simplify it. How to simplify? We have to find out the h from this equation. Okay, h from this equation we have to find out. In any way you can find out the h. Okay, I want to do one thing. I want to write the reciprocal equation. R plus h is equal to, we will get as r n square by n square minus 1 you will get. I want the h. H is equal to, we will get as r n square by n square minus 1 minus r you will get. You simplify it, and r is common at here. Then n square by n square minus 1 you will get. Then h finally you will get as h is equal to r into r by n square minus 1. This is the formula, right? Finally you got. Understood? This is about escape velocity, and if you throw with certain velocity, right, how much height it will goes. Next topic. Next topic is the orbital velocity. More 10 minutes I will take and I will close. Orbital velocity. After the orbital velocity I will close. Okay, what is orbital velocity? Orbital velocity means what? Orbital velocity. Orbital velocity means it is just like simply satellite velocity. You know, satellites will be revolves around the earth. Similarly, here to revolve around the earth some velocity is required. That velocity is called as orbital velocity. The minimum horizontal velocity, the minimum horizontal velocity, horizontal velocity, minimum velocity, horizontal not required, just minimum velocity required. The minimum velocity required, minimum velocity required for a satellite to revolve around the earth is called as orbital velocity. Okay, orbital velocity is the velocity that required to revolve around the earth. Now its formula I am going to derive. Very simple, within 5 minutes I will close. Okay, in order to move in the circular path, some force is required. What is that? Okay, for example, this is the earth. This is the earth whose radius is capital R, and from h height, okay, we are throwing one satellite to revolve around the earth. This is the satellite that we are throwing with certain velocity, v naught. Thank you, Ji. With certain velocity v naught in order to revolve around the earth. Then that velocity is called as orbital velocity. Right? This is the object. Consider satellite. Okay, here it is launched at h height in order to move along the circular path. With what velocity we have to project the satellite? Okay, in order to revolve around the earth. It will give the information about the earth. Na? Consider a satellite of mass small m revolves consider a satellite thrown with velocity VO in order to move it in order to revolve around a planet to revolve around a planet. How much velocity we have to give? We are throwing with velocity v naught. Then in order to revolve, what required to move in the circular path? Centripetal force is required, right? But this earth attracts the object towards the center. That means now in this case what happens? The gravitational force will be there. Okay, gravitational force between planet and satellite servo size centripetal force. In order to move in the circular path, centripetal force is required. And who is providing the centripetal force? Centripetal force should act toward the center of earth. Then the condition is that centripetal force should be equal to gravitational force. Okay, while deriving the escape velocity formula, we used the condition that kinetic energy equal to potential energy. But while deriving the orbital velocity formula, centripetal force equal to gravitational force condition we have to take. To move in the circular path, centripetal force is required. Centripetal force formula is what? mv square by r. We derived in the previous class. Okay, r is the radius of the circle. But what is the radius of the circle in this? Radius of the circle is small r. Okay, mv naught square by small r is equal to, the small r is r plus h, right? Directly we write, no need to write the two formulas. mv naught square by, this is r plus h, radius of circle, along with the satellite moves, mv naught square by r plus h, because centripetal force formula we know na, mv square by r. And gravitational force between these two is what? G. This is capital M and this is small m by distance square, right? Universal gravitation law. Distance between these two is r plus h, distance square, right? That's all. Derivation is almost completed if you know this condition. R square will cancel, this is small m will cancel. Then what you are getting? A v naught square. V naught square is equal, we are getting as dm by r plus h. Then I want the v naught. V naught formula is under root gm by r plus h. That's all. This is the formula for the orbital velocity. In order to move in the circular path, to revolve around the satellite, we have to throw an object with certain velocity. Right? In order to revolve around the earth, we have to throw the satellite with certain velocity. Satellite take the photographs of the earth. It will study the atmosphere and it will give more information. In the communication also we will use. Right? Then that satellite to launch with what velocity we have to give. The rocket will launch the satellite. The satellite is taken to certain orbit, certain height with the help of rocket, and the rocket throws the satellite at a certain velocity. Then the satellite will continuously rotate around the Earth or any other planet. Okay, this is the formula for the orbital velocity. Now, till now, any doubt? Is it clear, students? Orbital velocity, escape velocity. In these two, anyone will come in the final exam. Okay. derivations will come. But now, okay, already I stored the syllabus for you also. You prepare more in the chapters work, energy, power, and the three chapters, last running three chapters, you prepare properly. Laws of motion also I gave lateral students. I will prepare one lecture for the laws of motion, and with that you can learn. Okay. Where it is going? Okay, last 1 hour onwards it is working. That's why uh, now it is stops to work. Okay, within 2 minutes I will close. Right. Then I will derive the another formula for the orbital velocity. Then after that I will close it. Okay. Right. Let us start. In terms of acceleration due to gravity, I want. In terms of acceleration due to gravity. Right. Let us continue. And what is it? Here we got the orbital velocity formula. This we can consider as equation 1. But we know acceleration due to gravity on surface of Earth is g is equal to gm by r square. Then from this gm is equal to, we will get as gr square. This you substitute in that equation, then you will get as v